Okay, guys, I'm back. Let me see if now I can share my screen fine. Okay, I hope you would be able to see my screen now. Okay. Okay, guys.
Yeah,
Yeah.
Jyoti, there is one question. Will you be able to answer that? Miss, would you
Mhm.
like to answer that first?
Okay, tell me. Okay, somebody has asked on QA. Okay. Uh, I am not from computer background. I'm just aware of very basic. So, no. So you don't need to go into that much of detail. Okay, it's just you should know like how, what are various components of networking. So I think after today's session, you'll get the basic, what I want you all to know. So I'll give you what you need to just study. I think 1 hour of a study around those concepts would be enough. Okay.
Thank you, Jyoti.
Okay, guys. So I'll cover 4 topics. Okay. So first we'll talk about basics of networking. So what exactly we mean by network. Okay, and then we'll study the translation from on premises to AWS. Okay, so how everything which was there on your physical layer or your actual data center, how has that been migrated to AWS, and then in that only we'll study about VPC, which is your virtual private cloud, and then we'll talk about CIDR, subnets, okay, route table. So we'll be going, today is a theory session. Okay, practical sessions we'll have after I think 2-3 more lectures. So this topic is more about theory and concepts. Practically we'll plan it after 3-4 lectures. Okay, so the person who asked this question can also follow me along. So study what I'm telling you, that should be enough. Okay, even for me networking is quite new. Okay, so I'm also studying from various sources and I'm taking only that information which would help me make understand things on AWS. Okay, so yeah, so when we say network, what exactly we mean by network? Okay, so it's like group of computers or devices which are connected. Okay, and why we have connected various devices, because we want to share our resources. You must have seen, okay, in your college days, college time, you would have a lab. Okay, so all the computers on that, in that lab would be connected. If you save any file at particular location, your friend is able to access it. Okay, so in short, network is you are connecting resources, okay, so that you can share stuff. Now, to connect to different devices, I'm sure you would require some, uh, I mean, to connect those computers in on your lab, there were many devices which were required. You must have seen in your labs, there would be one machine, there would be a router, hub, all those things. Okay, so let's understand what exactly is the role of these devices, like what hub does, what switch does, what is the role of gateway, router. And in AWS you just have to understand gateways and router. Okay, hub, switch, bridges, if you know, it's good, you'll be able to form the correlation. Okay, so I hope you all understand that when we say cloud, it is actually a data center, but we don't have access to that data center. Okay, so all those functionalities which you are getting from the cloud, okay, on that system, on AWS, like wherever their regions are, all these devices would be placed. Okay, there would be hub, there would be switch, there would be router, repeater, modem, all those stuff, but we don't have access to those things. So for us, everything is virtual. Okay, then we'll talk about network. Okay, so you must have heard. So easiest one is PAN, your personal area networks. Like for example, right now I have a Wi-Fi connection with me. Now with that Wi-Fi, I have connected my laptop. Somebody would have connected their mobile. So it's your personal area network. Okay, so their range is also 0 to 10 kilometers. I think kilometer it's high. I meant 0 to 10 meters. Okay, then you have LAN, which is your local area network. So think about it as your computer labs, which you had in your colleges. So that is your in a building, you have connected machines. Okay. Then a MAN is your metro metropolitan area network. So where in a city, when you are connecting your computers, your nodes, okay, so that's your MAN. And then WAN is your wide area network. Okay, so it's like you India's network, that is your WAN when you are talking about country level. Okay, so you have country, you have got your state or city, then your personal at home setup which you have done. Okay, now since you are communicating across different networks, okay, so there has to be some rules and regulation. So we have a protocol, so there are various protocols which you would have studied in your college, which is like TCP, IP, UDP, and then you would have heard about the OSI model. Okay, so why these protocols or models are required? Because they form a set of rules which the devices which are there in a network needs to follow. Okay, so this is the example of one small network. So you can see you have your internet, you have got your routers. So I'm sure everybody would have seen routers. Okay, so your device is connected to router, which in turn is connected to internet, right? So it's a wireless. You don't see a wire connection from your laptop to a router. So that's a wireless. Okay, then these are your devices. Okay. Yeah. So let's understand our first network device, which is hub. Okay. So what is the role of a hub? Okay. So now understand if there's two laptops, okay, say Faz laptop and my laptop, and I want to send something to Faz. Okay. So there is this intermediate device, which is your hub. Okay. So all those devices, you would have seen some boxes like these in your lab. Okay, so you have see various ports open. So your machine would be connected, my machine would be connected, and Fast machine would be connected. So whatever information I need to send, I'll send it to hub first, and then hub would send it to other nodes in this device. So when I say node, it is your computers which are connected. Okay, you can connect your printer, you can connect other things as well. So in this picture we have taken, there are like say 4 computers, they are connected together. Now, what is the disadvantage of this device is it's not intelligent, which means I wanted to send, see, I wanted in a lab, for example, some exams were going on and we were in a group of 2. So I just wanted to share my solution with Faz. But now what would happen? I have kept it on the network, yeah, or I have sent the message to Faz. So it first went to Hub and Hub would broadcast it to everybody. So everybody would be able to see my solution. Okay. So then came a concept of switches. Okay, so you can say they are intelligent hub. Okay, so here they have kind of say table. Okay, again virtually I'm trying to explain. So now if I want to send something to Faz, so this switch would have source address and destination address. So this will ensure that whatever Jyoti is sending, it goes just to Faz and not to anybody else. So you're able to send private messages as well. Whereas in Hub, you were not able to send private message because it was more of broadcast. Okay. Yeah. So now let's come to router. Okay. So let's understand it in a layman language. For example, I wrote a letter. So there's this postman. Okay. He needs to deliver that letter to Faz. Okay. So what postman would do? He would find the shortest path. He would find a path which is free of congestion. Okay. So in the network world, that postman is your router. Okay. So it is like your traffic controller. Okay, so again understand, if postman has to deliver something from A to B, so the postman should know A's address, postman should know B's address, and should know which is the shortest way to go or route to. Okay, and then postman how it happens in a real world. So say I'm in Delhi and Faiz is say in Ahmedabad. Okay, so I'll send my letter. I mean whatever letter I post, it would go to the post office of Delhi. Then from there it would be sent to the post office of you say Ahmedabad, and from there it would go to Faiz. Okay, so routers, they are able to communicate or route traffic in a different network as well. So Delhi has one LAN, or you can say WAN, because we are talking about a state, okay, and then Ahmedabad is another state, okay. So you are transferring something from one, so don't go by my word that Delhi is a state, I'm just taking an example. So things from Delhi, your information is being sent to Ahmedabad, okay. So now there are two different networks, okay. So router helps you to communicate between two different networks as well. So it can be used for communication between your network, okay. So maybe in Delhi also, if there are 4-5 computers connected, so router would help me to transfer my data to those computers as well, and router would help me to send data from one network to another network as well, okay. Yeah, so you can see this example, okay. So you have a sales department, which is LAN 1, then you have another department, which is LAN 2, okay. Internally they are connected using switch and hub, okay, but then when they had to talk across, that time everything goes via router, okay. Let me know, guys, if any doubt till now. So these are very basic concepts. I thought we should just brush up and go through these. Okay, okay. Moving to next topic, which is bridge. Okay, so what bridges does is, overall network they divided into a subnet or a separate LAN, okay. So the whole purpose of bridges is to ensure that there is no collision between the data. So by collision means there's no loss of your data. So if I want to send something from here to here, okay, so first the information would go from this to the bridge, then from bridge to this computer, and then back. So you have a dedicated path where your information needs to go, okay. So there won't be a loss of data, or there won't be any collision. I see something on chat, let me see, what is it? Okay, okay, yeah. And now let's come to gateway, okay. So understand that, okay, I wrote a letter, and now the postman has arrived at Fad's door, right? So that door is the gateway, okay. Now when, if postman gets permission, then only he can enter Fad's house and deliver that letter, okay. So whenever you are talking, whenever you are sharing anything across internet, over internet, then gateway comes into a picture, okay. So this is what happens. Request goes from computer to gateway, then from gateway to respective server, okay. Then from your gateway to your computer. So in just simple, okay, this is how your information is being routed. So gateway, as the name suggests, it's the main door, okay. Once you've reached Fad's house, now letter would be delivered or not, it would depend where, if Fad gives him a permission, okay. He had my address, he had Fad's address, but just having an address won't suffice, okay. He should have the right permission to enter that gate and deliver that letter. And finally, NIC, which is your network interface card, okay. So you would have seen these cards in your motherboard. So what is the relevance of these NICs, okay. And you have got this port also through which you connect, okay. So there would be times when you'll be connecting your device directly to a network, okay. So that time you'll be connecting via cable. So what is the role of NIC? So when we say IP address, right? So every device in a network has a IP address. So ultimately that IP address translates into a MAC address only, okay. So it's like saying that, Jyoti, that's my name, that's my MAC address, okay, that's unique, okay. And now Jyoti can have multiple phone, so those phone are your IP addresses. So all the IP address which I get, or multiple phone number I have, they're it directly getting mapped to my name, okay. So again, all the IP address, if a device on a network has an IP address, so that is being translated to your MAC address, okay. Okay. So let's quickly revise, I would say. What exactly we mean by network? It's like you're connecting resources, so that you're connecting nodes, computers, or devices, so that you can share resources. And then to connect various resources in the network, you need some devices. Some are virtual devices and some are actually your physical devices. And then there are various types for network. You have PAN, which is your personal area network. Then you LAN, MAN, WAN. And since there are 2-3 parties coming together to do a communication, there has to be some rule. So those rules are called as your protocols, and some of the known protocols are your TCP/IP and UDP. Okay, followed by hub. Okay, so as you can see from the picture, this is for, you can say, your PAN or LAN kind of a network, wherein if you want to send any information, so if I want to send from here to here, it goes first to hub, and then hub would broadcast it to the other 3 computer. Okay, then we came across switch. Okay, now you'll understand what exactly is your MAC. Okay, MAC address. So now with switch, there is a possibility of sending a private messages. Okay, router, it is like a kind of a traffic controller. Then bridges, so they are there to avoid collisions, as in they form a small segments in a network. Okay, gateway. Okay, so gateway comes into picture when somebody wants to talk, or whenever we want to connect to internet. Okay, so when our device gets connected to internet, it is through gateway. Okay, so we'll study about gateway in AWS as well. And then NIC, which is like example of phone number and your name. So your name is unique, so your MAC address is unique. You can have multiple phone numbers. Okay, so and what is that phone number? That's your IP address. Okay, so when we talk about IP addresses, so we have got two kind of IP address. One is public and another one is private. Okay, so in a network, when we say private IP address, okay, so in AWS, for example, I have created 2 instances. Okay, so you'll see a private IP address and a public IP address. So with private IP address, there is no requirement of internet. Okay, you're not talking to any third party. So from, if those 2 EC2 instances I have created on in same VPC, I'll come to what exactly VPC. For now, understand that there is one entity which is VPC, which is your virtual private cloud. So there I've created 2 computers. Okay, those 2 computers or your EC2 instance have 2 address. One is their private address and another one is their public address. So with private address, I can talk to one another. Okay, one EC2 instance can talk to another EC2 instance with respect to private address. Okay, but if they want to talk to internet, if I need to connect to the internet, then your public IP address comes in picture. Okay, and how do you define IP addresses? There are 2 kind of IP address. One is your IPv4, which is of 32 bits. Okay, so we divide it into octet of 8 octets. Okay, so 32 is like 8. 4 octets are there. Okay, then IPv6, it is consisting of 128 bits. So why we had to move from IPv4 to IPv6? Because with IPv6 you get more address. Okay, as you know, like we are going towards IoT. Okay, we are going towards home automation, this, that. Now every devices in that home automation or in IoT, okay, that needs a IP address. Okay, so if we go by IPv4, then we might run out of IP addresses. Okay, so that's why we are moving towards IPv6. Okay, so here is small difference for you all, like what exactly we mean by private IP address and public IP address. So as the name suggests, these addresses have local scope. Okay, so we have something, a box name as VPC. So anything in that VPC can connect directly. Okay, we don't need to go over the internet. So how they can connect directly? It's with the help of their private IP address. But if I need to talk outside my that box, which is VPC, in that case I would need a public IP address. Okay, provided by router, provide these addresses using NAT devices. Okay, all this, let's understand just the range. So your private IP address has this range. So you'll when we'll go ahead and create a VPC, okay, so that time we'll be using these ranges only to come up with the IP address for all the EC2 instances which we have in our VPC. Okay. Okay. So you can read about this. Okay. And this is just a gist. I came across a site, kids.kindle.in. So they have explained kids these terms. So if you don't know about the networking, that's a good site to refer to, because they have given all these things in a very simple language. Okay. So this was all about our physical network, which consisted of various devices. Okay. And then we talked about the different kind of IP address a device can have. Okay. And we understood, like, okay, why we had to go from IPv4 to IPv6. And we also understood that IPv4 consists of 32 bits. So, but for our ease of use, we have divided into 4 octets. So now we don't write 0000.00 something like that. We're just writing it like, okay, 172. Okay, so this you need to convert it into a binary of 8, then 16.0.0. So in total these are your 32 bits. How they are 32 bits? This is of 8, again this is 8. So I hope you remember, right, from convert, how to convert uh, digits to binary. Remember we did in our college days, like 2 to the power 0, 2 to the power 1, 2 to the power of 2. I wanted to show all this on whiteboard, so I'll take that up in next session. Today I was not. Uh, okay. So finally, whatever I talked, okay. So we talked about internet, we talked about router, we talked about LAN, switches, hub. So all these things in AWS has translated into a VPC. Okay. Now I hope you can form the relationship. Okay. How is on-prem and how is your AWS network? So this is your physical and this is your virtual. So now when we say VPC, I'm sure now you'll understand, oh, if we are saying VPC, that means we've got certain IP ranges. Okay. And those IP ranges, each IP has been assigned to every device in the VPC. Okay, so in device by device, you can say your EC2 instance, etc. And now if they want to communicate with each other, there would be some switch, there would be some router. Okay, so all these things is mapped to your VPC. So internet remains same. This all entire part is into VPC. So now when we go ahead and create our architecture, so we have to take care of all these things. Okay, we have a large, we've got a good IP range, for example. We got some IP range which can give us like 6,000 devices I can have in VPC. So now you can decide, okay, you want to have a single LAN kind of a setup, or you want to have a WAN kind of a setup. Okay, how do you want to tell your router, okay, which is your traffic controller? So how would you tell router the path? Okay, if something is coming from, say, one EC2 instance, okay, and that wants to communicate with the internet, okay, which route to take to? So all these things we'll design. Guys, stop me if you have any question anywhere. Is it okay till now? Sagar, Vinod, Ashok, Faz. Am I making sense? Are you able to follow?
Yes, yes, I am good. Vinod is also saying that he is also good.
Okay. Sagar, Ashok, are you both good? Should I proceed ahead? Okay, I'll take that as yes then. Okay, no response is yes for me. But if you say you're not able to understand, I can repeat. Okay. Yeah, so let's move to your, again, just for understanding. Okay, so as I told in previous lecture as well, I see something on chat. Acha, there is a question. I can't see question. I see there is a notification for a question, but why can't I? Okay,
Maybe
will
because I started reading the question, I don't know. Maybe that's how it works. So it's the question like, ma'am, can we get screen recording? Actually, my device got restarted and I missed all the part where you explain why we go for IPv6. So I don't know who has asked this question because an anonymous question, but we are already recording this session. So you can refer to the test chat YouTube channel. It will be recorded, uploaded there later. I will share the link to the test chat channel here in the chat box.
okay, thank you, guys. Yeah. So again, just another diagram. So visually, when we see things, we are able to form correlation better. So again, see, we had this traditional IT network, which consisted of this physical network. So okay, so these three computers, they are connected to hub. Then another, I formed another. So you can say, okay, this is class. We had sections, right? So maybe this setup is for section A. Okay, and this setup is for section B. Okay, now what if a student from section A wants to share something to student from section B? So router comes in a picture, it tells, okay, how to go about it. Okay, so this router would have address of uh, computers which are there for section A, and it would also have address. So when I say address, it would be a MAC address, but we don't specify MAC address. We talk in terms of IP address. Okay, so this router would have IP address of this section B computer as well. So now somebody wants to communicate. So for example, Faz was in section A, I'm in section B, so I can communicate using router. Okay, so same thing in AWS, how we have broken down this in AWS. So this entire network, okay, so your college, for example, okay, we are talking about your college, then there are these section A, section B. So the college is your virtual private cloud, it's your VPC. Okay, the sections are your subnetwork A and subnetwork B. So I'm in section A, maybe I have a different subject. In section B there are some other subjects. Okay, so now if student from section A wants to communicate with student from section B, they can communicate it using router. Okay, there is no direct, okay, it would go via router. Okay, but if student from section A wants to communicate with something on the internet, then there would be internet gateway would be required. Okay, so again, let's again bifurcate your VPC, your regions, availability zone. Okay, so remember, we studied about some services like S3. Okay, so you have your account. Okay, so when you log into your account, okay, your IM user or route 53. For now, understand route 53 is your DNS. Okay, so whenever I write say www.testchat.com, okay, that gets translated into IP address. Why it needs to get translated into IP address? Because on a network everything is being referenced as a IP address, but everybody, you cannot remember test chat IT. Suppose test chat had IP address as 10.1.0.2. Okay, so it's difficult to remember this. Okay, and so we came up with something called as domain name resolution. So we gave a name. Okay, now I start forming a relationship. Okay, so we are saying there is some name TTC chat, it is being uh, ultimately gets translated to an IP address. So there would be some mapping somewhere in the network, it would be stored, which would be helping. Okay, so you see these GoDaddy and also they provide you IP address, they provide you these domain name, right? So ultimately that domain name is mapped to a IP address. Now when you log into your account, what do you see? You see regions. Okay, so what are the services which work at the region level? They are your S3. Okay, so on these you don't have a control, you cannot decide the traffic of route 53 and S3. Okay, that is not in your control. What is in your control is whatever is being done in your virtual private cloud. Okay, so what are the services which is available under in your VPC layer or at your subnet layer? Those are your ELB. So when we talk about load balancing, when we'll study about load balancing, so its scope is at the VPC layer. Okay, and then your EC2 instance, which is something which you create inside your VPC. So you can control the traffic for ELB. So by traffic means you can create that mapping or table for anything which is inside your VPC. So what is inside your VPC? It's your ELB, EC2, RDS, etc. But anything which is outside VPC, it's not in your control. That is managed by AWS. Okay, you don't manage the traffic or network for those services. Okay, yeah, we have time. So let's go to next topic, which is your VPC. So first, let me just show it to you what exactly is VPC in AWS. So we study a lot of theory. So when you create a instance, right? So I see I created this instance. So now you can form a relationship, right? Instances like there's this one computer. Okay. So this instance has a private IP address. Okay. And which form we are taking IPv4. Okay. So it has a private, sorry, I should show it from here. Okay. So see, you have your private IP address. Okay. Then you have your public IP address. Okay, so what does this mean? So if I create another EC2 instance in this account and in same region, and I give same VPC, okay, this VPC. So if these two instances, they want to talk to each other, how they'll be able to do it? It would be through this private IP address. Okay, but if I want to connect my system, this EC2 instance with internet, then which IP address I'll use? I'll use public IP address. Okay. But ultimately, we will study about NAT, network address translation. So ultimately, your public IP address is mapped to your private IP address. So there would be a service known as NAT. So that NAT would convert your public IP address to a private IP address, because your system knows only your private address. So these are like, understand, again, this I'm telling just for reference, that understand them as alias. Okay, so they don't exist, but they have been given so that if I need to communicate on the internet, how I can communicate using this IP address. Okay, but ultimately this gets translated to your private address only. Okay, now you see, so you have your instance, it has got two address, one is your private, another one is public. Okay, and this has these two things, which is like VPC. I haven't created VPC, it is by default the VPC which I got. Okay, so let's see how does VPC look like, what exactly is there in VPC. Okay, so guys, what do you see in a VPC? You see something like this. We'll come to it in our next topic. So for now, understand there is some IPv Cider. Okay, so what is it? We'll study. Okay, and then yeah, the route table which I was telling you about. Let's see how does this route table looks like. So you have route table ID VPC. Right now, there's nothing in this route table. We'll go ahead and create a route table in our upcoming section. But let's see if we do create route table. What do you say? So you see a VPC. Okay. So for example, I want to create a route. Okay. This is route table. So what do you see here? We are saying destination, it's some address, and target is local. So whenever you see local, that means we are talking about communication within VPC. There's no internet involved here. Okay, so it's something which is there in your VPC, two instances, if they want to communicate with each other. So if you see a target as local, that means yes, there is a rule in a route table which says yes, the EC2 instances in my VPC, they can communicate with each other. And you'll see this I didn't create, it was created on its own. Okay. So by default, route table has an entry in your, what do you say, AWS. Okay. Similarly, let's understand about subnet. So you can form that picture. College is your VPC. Okay, so your college name is VPC. Now in that and that college has a name which is being referenced by private IP address. Okay, but to the world we have given some name. Okay, some other name. So that is your public IP address. Okay, so this comes into picture when something in your college, I mean any device in your college wants to communicate onto the internet. Okay, example, you from your college computer, you want to access Google or Facebook. Okay, so that time which IP address is used, it's a public IP address. Okay, so who does that conversion? It's NAT. It converts your public to, so traffic would go from your college computer to Facebook, and it would come from Facebook to your computer again. Okay, so Facebook understands only your public IP address. Okay, so NAT would convert your public IP address into a private IP address, because ultimately private IP address is my address. Okay, public is kind of a alias. Okay. Now the sections, there were two sections, remember, section A and section B. So that section A and B is being referenced by subnet. So let's see what is there in the subnet. Yeah. Okay. So you would see a difference here. It was /20, but here it's /16. So what is it? Just keep note of it. We'll study about it. I am just trying to point you a difference. So the address of my VPC is 172.31.0.0/16, and that of my subnet is 172.31. So first two prefix you see it's same, .16.0/20. Okay, and it says 4090 IPv4 addresses. So what does that mean? That means you can connect you get in this subnet, you can have 4,000 EC2 instances. Okay, let's see in VPC what does it says. Okay, so VPC doesn't have okay, yeah. So why we are saying that VPC, we are providing the number of IP addresses it can have is like in a section how many student you can have. Okay, so I know there, like I have a capacity of say 1,000, and now I can divide it into batches of 250, 250, 250, 250 each. Okay, so 4 batches. So I'm telling, okay, every batch has a capacity of 250 students. Okay. So let's move to the slides now. I know for first time it's little confusing, can get little confusing. So today just hear the terms. In next section we'll again cover these things in detail. Abhi, just get yourself familiarized with these things. Okay. So now, what are various VPC component? You have a Cider. So now what is your Cider? The IP address which I showed you here. This is your Cider. Okay, and this is following IPv4. Okay, so let me open this. Okay, now for example, this is my VPC. So I'm in a region, this is my VPC. So in this VPC, how many devices I can have would depend upon the IP address. So Amazon, they recommend certain IP addresses, which is these. So you can have IP ranges like this. So for example, let's take this for convenience. So suppose I give an address like this 10.10.0.0 /16. Okay, so what does this is your Cider notation. Okay, this notation is called as Cider. Okay, so what, and I told you in IPv4 there are how many bits? 32 bits. So this is of 8-bit, 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 and 8-bit. So when we talk about IP addresses, we keep certain bit for network. Okay. So how would I identify that this letter is coming from Delhi? Okay. And the letter which is going to is for Ahmedabad. So you have your network ID. Okay. And then you'll have something called as host ID. So for this only I was looking for a whiteboard, but didn't work. Okay. So now, okay, very good. Jyoti, you're saying that this is a Cider notation. It consists of a network ID and host ID. So how would I know which is the network ID and which is the host ID? So you'll get to know what is your network ID by this digit. Okay. So 16, that means these two bits are for your network ID. So whatever instances you launch in this VPC, their first 2 octets would be fixed. Okay, got it. So for host, what are my number of bits which are stored for my host ID is these two, which is 16. So 2 to the power of 16 would give you the number of instances or devices you can have in your VPC. So which comes out to be 6, 5, 5, 3, 6, something like this. So you can have these many devices in your VPC if you give the Cider as 10.10.0.0.16. Okay. Now I decided that, okay, I'll create a subnet. Okay. So now this was my VPC. I'm breaking it into 2 networks. Okay. And I want to have 4 subnets here. By I'm dividing my complete network into subnetworks. Maybe the kind of instances I want to have in this subnet is different than kind of instances I want to have here. Similarly, it's like this is section A of a class and this is section B. Okay, they are science students and these are my commerce students. Okay. Now, how do we come up with the ranges? Okay, so for example, I have 256, strength of 256, 256, 256. And here also it's 256. Okay. So what is 256? It's 2 to the power of 8 is your 256. Okay, so that means I need to keep my 8-bit this for my host and remaining 3 would be for my network. Okay, so if I talk about subnet 1, it would have addresses like this now. 10 dot. First, let's understand how would now subnet would look like. 0. And this is the bit which would vary from 1 to 255. Okay, are you getting, guys? So you had a network. Okay, so I had to create a VPC. So I took a Cider notation like this because AWS recommends us to take something like this. It gives you the ranges. So I took this 10.10. So you can take from 0 to 255, right? See this second part, 0 to 255. So I took 10.10.0.0/16. So what this 16 is telling me, the 16 is telling me the number of bits which are stored for my network ID. Okay. Yeah. So the remaining 16 would be used for my host ID. So when I say remaining is for host ID, that means it's for all the EC2 instances which now I'm going to create. These two, combination of these two would help me to create those unique IP addresses for all those EC2 instances or RDS or whatever, okay, service I'm using in VPC. Okay. And again, as we told you that you need to divide your network into sub network. Okay, so I thought that I'll go ahead and divide my network into a 256. That means in a subnet there can be 256 device. So what is 256? It's 2 to the power of 8. That means I need to keep my 8 bit for the host and remaining 24 bits for what? For network ID. So if I talk about Cider notation, so Cider notation would look something like 10.10.0, because I have to play dot 0/24. Okay, this is for subnet 1. Now let's talk about subnet 2. So it would be 10.10.1.0/24. That means in subnet 2, my IP addresses would be something like this: 10.10.1.1, then 1.2, 1.3 until 255. Okay, I'll pause for question. Okay. So Vinod and Faz, is it confusing or it's clear?
It's clear to me.
What about you, Vinod? You can write in chat. Yeah. So that's good. So purpose for today's session is this only, that theoretically you should be able to follow. In first go, you won't follow everything end to end. Yeah. Okay. So now if somebody says Cider, you'll be able to follow. Okay, what exactly is Cider notation? Okay, so see this. Now if you read this VPC, I'm sure you'll follow. Okay, what exactly we mean by, oh, yeah. So 172.13.0.0.16, that means my 16 bits are fixed for network and remaining 2 are for host. Okay, and how many host I can have, host IDs I can have? 2 to the power of 16, 8 for this, 8 for this. Now I go ahead and divide my VPC into subnets. Okay, and why do I need to divide VPC into subnet? Same, you divide a class into sections. There is a reason for dividing class into 12A, 12B, 12C. So you understand, oh, 12C is like commerce, 12A is maybe PCM, 12B is PCMB. Okay, so similarly in your VPC also you have a subnet. That means each subnet would have different kind of setup. Okay, maybe their EC2 instance, in one it's T2 micro, in another subnet it's not T2 micro, it's something else. Okay. So Cider, you've understood Cider. It's just a notation which gives you the ranges. Okay, and these are the ranges. Then we talked about subnet, which is dividing your network into subnetworks. Then internet gateway was if I wanted to communicate to internet from my EC2 instance. So for example, from my EC2 instance, if I want to access Google or Facebook, so now traffic would be routed via internet gateway. Okay. Then virtual private gateway and customer gateway. What are these? For example, you have on premises Okay, or you can say you have a customer's network. Okay, and then you have got your network, your company's network. So if they want to communicate, how would they do it? They do it through these virtual private gateway and customer gateway. So the gateway which is at the customer end, it is called as customer gateway, and the gateway which is at the VPC end, that's your virtual private gateway. And how do you connect? It could be a direct connection between these two, or it could be through VPN. Okay, let me draw it for you. Okay, that way. I hope it lets me draw something. Oh, which is a bit erase. Okay. Do you guys see any option to erase this completely?
Maybe you can try to refresh maybe URL.
Yeah, let me do one thing. Let me just delete all. The other two attendee, they dropped off. I don't know whether they were not able to follow or some network issue.
Yeah, no issue.
Yeah. Okay, guys. So let me just. So this is your network. This is your applications, and maybe here is customer, and my customer is on premise. So this you can understand as say this is pay you. Okay, this is pay you, and this is say Flipkart, for example. Okay, now if I want to form a connection between these two, so how would I do it? Here there would be a service. This is my virtual private gateway. Okay, and this here the gateway. And now you guys understand, right? Why do we need a gateway? It's like your house gate. Okay, and this is your customer's gateway. Okay, so if I want to connect this with this, at the AWS side, it would be virtual private gateway, and at the customer end there would be customer gateway. And how I can have a connection, either it would be via VPN or it would be a direct connect. So we'll study about these things also. Direct. And if anything in this VPC wants to connect to internet, then it would be internet gateway. Here is your internet. Okay, right? And within, if there is two subnets and they want to communicate with each other, then there would again be a router here. Okay, which would help you to communicate between these two. Yes, I showed you a route to table which had a entry and local was written. Okay, so that means any device in this subnet can communicate within say device of same subnet or other subnet. There won't be any internet connection required. Okay, but if something wants in this subnet wants to connect to internet, then it would go through IG. Okay, so where is all these mappings saved? It is saved in a route table. So we call that table as route table. So route table are also of two kind. One is your main, so which is at your VPC level. Okay, and then you can have your custom route table as well, which is at your subnet level here. Why do we need a custom and why do we have a main? So custom is like, okay, when you want to communicate here within your VPC only. Okay, so you can just keep your entries. Okay, so if give your Cider notation and write here local. Okay, but if I want to communicate in through internet, and even whatever is there in my subnet A wants to communicate with the internet, even things in subnet B also wants to communicate into to internet. So what the common routing, you keep it in your main table, okay, and the one which is like specific to your internal system, internal instances, you keep it in your custom table, okay. Yeah, so see, your route table looks like this. So you've got, there are many types. For now we'll understand two. So you have main route table and you have your custom route table. So main route table is like, okay, so entry like this suggests that all the devices in your VPC or in your subnet can connect with another device in same VPC and in same subnet or a different subnet, okay. But if I want to connect to a internet, so this is for internet, okay, so then this is like destination from my system where I want to connect to internet, okay. That's why you see destination like 0.0 because I don't know Google's IP address, right? So I've written 0.0.0, which means everything, okay. And here I'll provide the ID of internet gateway. Now do you get the logic that whenever you see a request from one EC2 instance to another EC2 instance, that time the target is local. So local means, oh, this is for within the VPC or within the subnet, okay. But when you see something like this, that means here the route needs to be decided by your internet gateway. So now my traffic would go from here subnet to internet gateway, okay, and then to internet. But if something is written as local, that means it is like within the VPC communication. We are talking about that, and that would be done through your private IP address. Okay, but with internet, you'll have your public IP address. Okay. Yeah. So that was the last topic. Like subnet will study in detail. Then you have a concept of private subnet and public subnet. So what do we mean by private subnet? So if you don't see a entry of internet gateway in a route table, okay, that means that's your private subnet. We are talking about private communication. But if your route table which you create at the subnet level, it has entry for internet gateway, that means it's a public subnet. Okay, we are saying that the devices in this subnet can communicate through internet. Okay, guys, I'll stop sharing. Let's just revise again before I stop sharing. Okay, so we'll start from very basic. We understand, okay, what do we mean by network and what is the purpose of having a network. Then how do you connect devices, your systems in a network? It is with the help of network device. And there are 4-5 kinds of a network. You have PAN, which is like what is there in your homes, then LAN, MAN, WAN. And then since we are talking to a devices, okay, so there has to be some set of rules and regulations, okay. So hub, it's like it's used for broadcasting and it's less intelligent. This is the device, how it looks like. All your these computers are connected by this port, okay, and it's less intelligent. Like whatever I want to send it to Faz would go to Vinod as well. Then we talked about switch. So switch is mainly for your MAC addresses. That means this switch knows your source and it knows your destination. So you are able to send a private message. Then router, it's like your traffic controller. In AWS, how we are managing that traffic controller? By creating a table. So that table consists of destination and the target. So the target, if target is local, that means this request is for a system which is within your VPC. But if it target is internet gateway, that means we are trying to access something which is there on the internet. So that would be done via internet gateway. So that internet gateway or your Route 53, they'll take care of those DNS resolution, etc. Okay. Then bridges. Bridges is like it to avoid collision. What we have done, we have divided our network into segments. Gateway. Again, if you want to communicate on internet, gateway is your interface for that connection. So same interface we have in AWS as well. Okay, NIC, ultimately when we say MAC address, that is your NIC. Okay, and as I told you, like your name is unique. Jyoti is my name, that's my MAC address, and phone number is my IP address. Then we talked about, okay, there are two, public and private. Private is like, okay, this has a local scope. So any device in the network, they would know my private IP address. Okay, we'll be communicating through our private IP address. Okay, but if we want to communicate over internet, then it is done via public address. But ultimately, those public addresses get translated to a private IP address only, and that is done by NAT. Okay, so we studied, okay, how on-premise physical network gets translated to AWS network. So see, in short also, see, there were so many things. All those things have been replaced by a VPC. Okay, so think about the idea also, like AWS, how they thought about this idea of cloud and all, how they were able to translate all this. Now I don't have to think about switches, router, LAN, this, that. Ultimately at the back, this is being translated to this only, but to a user you are just seeing one VPC. Okay, so we studied one more example, like, okay, so if you want to divide your network into sub networks, okay, so how do you do it? So your VPC has one Cider range. That range you're dividing into a multiple ranges, so which is your subnet. And why do we want to divide? Maybe they have a different requirement altogether. Okay, maybe you have a QA environment, you have a production environment, you have a sandbox environment. So for each environment you have subnets. Okay, router is for traffic. Okay, so how does this router work? It has got a table, routing table. So one is your main table and another one is a custom table. Okay, so custom is like, if you're talking about specific things, something which is specific to subnet A or something which is specific to subnet B. So whatever is common, that you can do it via main route table. Okay. So this is what I was telling you. So you have control over the route, like, okay, you can specify the traffic at the VPC level. You can decide, okay, from EC2, how would traffic be routed to internet or to other VPC, etc. You have control of that. But anything which is at the region level or at the account level, networking of that is managed by AWS itself. Then we studied about the address, like how do you identify address? So it's a Cider location notation. So which is like, you specify the octets. These are like your 4 octet slash some value 16, 24. So what is that value? 16, 24, 25, all those specify in this 32-bit. Okay, how many bit I need to save it for my network and how many it's for host ID. So network is like to identify. Okay, maybe Vinod went ahead and took same Cider in, and even I took same Cider. Okay, or Vinod Cider is different than mine. Okay, so how do you identify, oh, this communication is happening across different VPC? So that can be identified by using these network IDs which you have placed. Okay, internet gateway, virtual private gateway and customer gateway. It's like, okay, if say PayU is one entity and Flipkart is another entity, and if they want to communicate, how they do it through gateways. So at AWS, that gateway is known as virtual private gateway, and at the on premises it is known as customer gateway. And in those two, you've got gateway, and now how you can connect, either it would be through VPN or through a direct connect. So each has an advantage and disadvantage. Then a simple route table. Okay, how does a route table look like? Okay, so main route table. So the route table that automatically comes with your VPC. Remember, when I created a VPC, there was a route table ID already associated that there. And when we clicked on that route table, we saw an entry, something like this only. Okay, custom route table is which you create. Okay, yeah. So, and then we talked about private subnet and public subnet. So private subnet in short, if the target is local, that is your private subnet. But if the target is internet gateway or something else, this target, if it's something other than local, that means it's your public subnet. That's it, guys. Any questions? Any thoughts, feedback?
Nothing from means no questions from my side. I will wait if Vinod has some questions.
Even do let me know feedback, like if you think, because this is little complex topic, if you think I should explain it in some other way, I should take more examples, so I'm open for that feedback as well.
Yeah. Vinod is saying all good from his side. He's going more to learn further, and from my side also, the feedback is yeah. So Vinod is saying this is good so far. Your way of experience is really useful. My feedback is the same. The way you started how with first you started with the real networking and real networking concepts and example. Then you got into the AWS networking and all those examples. So you were able to correlate the things that how it was working in how it is working in the like normal networking which we have studied or learned about, and how it is functioning in the VPC, and the way you explained it via whiteboard and was, so I think it was good. This was like very good. Yeah, thank you for that.
Yes, thank you. In fact, see, I would just like to highlight, there are times just to make things simpler, I give some examples. Okay, so they are not like a true example, they are just purpose for explanation and to help you make a connection. Okay, what is being said.
Yes.
Okay, guys.
Yeah, but that's how it's we are able to understand the basics. So here miss, so if you would have provided the actual terminology, technical things, we might not be able to get that much idea, but you gave it in like a layman's language, a very simple example. So that's why we were able to relate. And even the person that he was not from the computer background, he was saying that, so he would also be able to relate to that. So it was very good, I believe.
Okay, great. So yes, let's meet in next session, guys. Come prepared, like more you read, you'll be able to follow stuff. Okay.
Yeah, sure. Yeah, thank you so much for this session, Jyoti. Thank you.
Okay, bye guys. Bye Vinod, thank you for
Bye.
joining.